So let's talk about impact time and the safety aspect. So we know that force is equal to the change in momentum, which means the momentum at the end minus the momentum at the beginning, divided by the contact time. And the contact time is how long the two objects are in contact with each other. Now, the larger the contact time is, the smaller the force. And we know that force is related to acceleration. It is mass times acceleration. So if you want to create an object that is very safe, you want this impact time to be as high as possible so that the force experience is low. If the force is low, there's going to be a small deceleration. So small force, smaller deceleration means less injury to an actual person. So a lot of helmets, a lot of crumple zones in front of a car, they actually increase the impact time, therefore lowering the force on a person. This increases the rate of survival if there is a smaller force on a person. So something that is cushiony, that is going to slowly change the shape, so the impact time is longer. If you've got a hard surface, bang, you hit. There's a small, sharp impact time. Now, the thing about seatbelts is they increase the chances of survival because what they're doing is they're making the person decelerate slower. A smaller deceleration. So if this deceleration is smaller, the force acting on the person is going to be smaller. Let's say a object is traveling at 2 meters per second and it's 30 kilograms. And let's say the impact time is 2 seconds. So the change in motion, if it's traveling 2 meters per second and then it suddenly stops, is going to be 2 times 30. We don't need to worry about the momentum at the end because it comes to a rest, so the momentum at the end is 0. So the change in momentum is 2 times 30 minus the 0 at the end, divided by the impact time. And let's say the impact time was 2 seconds. So the force acting on the person is 30 newtons. So I want you to remember, when it was 2 seconds, it was 30 newtons force. What about if I made the impact time really short? I made it 0.5 seconds. So we still do the 2 times the 30 minus the momentum at the end is 0 because it comes at a rest, divided by 0.5. Now the force is 120 newtons. So the force has increased by a factor of 4 when I've decreased the time by a factor of 4. So you could see as I'm bringing down the impact time, the force is increasing, making the collision even more dangerous.